Recall lang tayo related dun sa mga discussion natin last meeting. So last meeting, yung mga diniscuss natin is yung sampling distribution of means. So we have yung 5 na theorems. Yung una nating theorem is related sa mean, where we have the sample mean of the sampling distribution of some given population of mean is denoted by u of x. Ito na nga siya. So yung mu or yung u of s is yung the mean of the population. And yung next naman natin is for the theorem 2. Dito naman is meron tayong ginagamitan ng variance or yung population variance natin. Pero for the theorem 2, the population is infinite and we have the sampling is random, or if the sample is finite and the sampling is with replacement. So ito yung for the sampling natin na with replacement. And kung paano tayo kumuha ng population variance, where we have yung population variance as sigma squared over 2. Or kapag standard deviation naman yung kunin natin, i-square root lang natin siya. And then for the theorem 3 naman is without replacement naman siya. Kapag without replacement, ito yung way kung paano tayo kumuha ng population variance natin. We have the sigma squared over n times yung lot size natin minus ng sample size over the lot size minus the sample size. And also, diniscuss din natin yung theorem 4 natin, which is yung if we have the population from which the samples are taken sa normally distributed with given na mean, at saka may given tayo na population, yung variance natin given siya sa normal distribution. And yung last natin na theorem is yung theorem 5. Ang discussion naman natin for the theorem 5 is the z distribution, where we have yung x bar minus the mean over the standard deviation natin. So, ito is pwede natin makuha siya kapag meron tayong possible na given na variance pa rin siya. So, yun nga, i-square lang natin yung variance para makuha natin yung standard deviation. So, continue lang natin for the hypothesis testing last time. Ito na yung naging discussion natin or nakatay dito sa discussion natin na to for the testing of hypothesis. Okay. For the testing of hypothesis naman, again, recall lang natin, yung hypothesis is a statement with a with the idea na to resolve yung problem para ma-determine natin na yung mismong idea natin is either true or hindi siya totoo. So we also use yung null hypothesis at saka yung alternative hypothesis para ma-determine natin if i-accept natin yung mismong idea natin or i-reject natin siya. So we have nga the types of hypothesis, which is the null hypothesis, which is also denoted as H sub 0, and we also have yung alternative hypothesis, which is yung nag-denote siya as yung H sub 1 natin. Ito is yung sa null hypothesis is based dun sa non-significance natin, significant difference, while yung alternative hypothesis is kabaliktaran ng null hypothesis natin. If yung null hypothesis natin is idea siya ng non-significant difference, dito naman sa alternative hypothesis natin is we have the significant difference. Kasi yun na nga siya, rejection siya ng null hypothesis, yung alternative hypothesis natin. And then we also use this example. We have yung sa kung paano natin gagamitin yung null hypothesis at yung alternative hypothesis. Before, yan, diniscuss na rin natin to. And as a continuation lang, we have the types of error, which is we have the type 1 and the type 2 error. For the type 1 error, we have yung rejecting the null hypothesis when the fact it is true. For example, meron tayong given na iniisip natin is with significant difference siya, or we have the non-significant difference. So, for example lang is ni-reject daw natin yung first natin, which is the null hypothesis, na dapat instead na inaccept natin siya, ni-reject natin siya. So, yun yung type 1 error. For the type 2 error naman, instead na i-reject natin yung null hypothesis natin, inaccept natin siya, which is hindi naman siya dapat i-accept. Kaya yung fact na yun is false. And then we also have here the level of significance. So sa level of significance daw, it is the probability of committing a type 1 error is called the level of significance. The level of significance is denoted by alpha, while the probability of committing the type 2 error is denoted as beta or yan. And then the value of alpha is equal to the probability of making an error in rejecting the null hypothesis when in fact it is true. Similarly, the value of beta is equal to the probability of committing an error in accepting the H sub 0 or the null hypothesis when the fact it is true. So dito pinakita lang din yung paggamit natin ng alpha at saka ng beta based din sa type 1 at saka sa type 2 error natin. And we also have naman yung choice ng value ng level of significance natin. So may range siya from 0.01 to 0.010. So usually ang ginagamit natin na level of significance is we have the 0.01, 0.05, 0.010. So yun yung madalas na nagagamit sa mga research. And then depending on the risk of the researcher is willing to form yung making ng type 1 error. So again, yung type 1 error natin is yung, balik natin. Ayan. So the type 1 error again is nireject natin si null hypothesis pero dapat is inaccept natin siya. So, yun yung tinutukoy dito, making type 1 error. And then we also have here yung types of tests, which is we have yung may area tayo, kung last time is nag-graph tayo through Z distribution, dito is pinapakita lang natin yung mismong acceptance region tsaka rejection region natin. Una, we have the hypothesis could be one-sided directional or two non-sided directional. For this one, we have na yung one-sided lang yung pinapakita niya. So the one-sided test is referred to as one-tailed test. If the alternative hypothesis is expressed in terms of greater than or less than, it is called one-tailed test. The rejection region lies only in one tail and of the distribution. So dito, pinapakita natin na itong part na to, let's say ito yung normal distribution natin. For the normal distribution, itong part na to, until dito sa line na to, itong whole region na to is the acceptance region. And then itong part na to is the rejection region. So one-tailed din siya. On the other hand, ito din, same lang siya. Ito yung part, itong part na to is the rejection region and itong part na to is the acceptance region. Well, for the two-tailed test naman, we have naman here na pinapakita natin na since two-tailed, so dalawa yung rejection region niya and yung acceptance region niya is within lang dito sa area na to, yung nasa middle. So we have yung range, given range for the acceptance region and yung mag-exceed sa region na yon, whether yung sa left hand or itong right hand natin is considered as the rejection region. And then for the step natin, for the hypothesis testing, first is kailangan natin mag-formulate ng null hypothesis or the alternative hypothesis natin. So we need to determine yung non-significant difference at saka yung significant difference sa pag-identify ng null hypothesis at alternative hypothesis. And then next is kailangan natin na mag-set ng significant difference. So for the significant difference, we can use the 0.01, 0.05, 0.10, depende dito sa isa-set natin na level of significance. And then next is to identify the type of statistical test as either one-tailed test or two-tailed test siya. So usually kapag may range naman siya, ito yung limit or yung limit natin, we have the two-tailed test. So kanina pinakita naman natin yung graph ng one-tailed and the two-tailed test. And next is to determine the tabular value for the test. Kasi na-discuss pa lang natin is the Z distribution. But for the statistics, we also have the T distribution or the chi-squared and the F distribution. So each of these have their own table naman. So yung na-discuss natin, we have the Z distribution. Napakita ko na rin naman yung table nito before na ginamit natin. And sa susunod, madidiscuss na rin natin yung chi-square and the F distribution. Aside din sa normal distribution din. So, next is, after natin ma-identify, based din sa value or din sa tabular value for the test, we need to compute the required statistical test. Ayun. And then, sunod is yung value na din sa mismong, based din sa computation natin. Dito naman, we have the significant difference, pero example lang to is for the critical values of Z or the Z distribution. So before, pinakita ko na nga yung table niya, we have only here yung one-tailed test and the two-tailed test. So paano ba siya titignan sa table? Let's say, we have yung one-tailed test. Ang significant level, or I mean the significant level for the one-tailed test natin is we have the 1.28. So ito yung hahanapin natin sa table, yung value ng 0.10. Well, for the two-tailed test, since ang two-tailed test is dalawa yung rejection region niya, so yung 0.10 is divide by 2 natin, or divide by 2, we have yung 0.05. So ito yung value ng 0.05 sa table natin ng Z distribution. Kaya yung 0.10, when we combine yung both na rejection region natin, yun yung for the two-tailed test, which is we have both 0.05 plus 0.05 is 0.10. And then for the 0.05 significant level for one-tailed test, we have the 1.645. And for the two-tailed test, kaya nakuha naman itong 1.96 is yung 0.05, dinivide natin by 2, we have the 0.025 kapag titignan natin sa table ng Z distribution. And then for the 0.025, for the one-tailed test, we have the 1.96. And kapag dinivide natin yung 0.025 into 2, we have the 0.0125 or we have the 2.33. Ito siya for the two-tailed test. Yun yung hanapin sa Z table natin. And then for the 0.01, we have the one-tailed test, which is 2.23. And for the 0.01 ng two-tailed test, for the 0.05, ito naman siya, 2.58 for the two-tailed test, which is kapag kinambay yung 0.005, we have the 0.01. Okay, so itong value na to, lahat na to, is gagamitin natin. Kasi for equivalent to ng value natin sa Z distribution, kapag nag-solve na tayo ng Z distribution, kapag ang given value, ang given natin is based sa significant level at kung anong type of test siya, one-tailed or either two-tailed test. Okay, for the first example, we have yung for the example problem number 1 natin, we have the mean score on a widely freshman history examination is 75. A history teacher at a very large university wants to determine whether there is statistical evidence for claiming that this year's class is not average. Given the following scores and assuming that the students in this class are a random sample from the population of students at the university, test the appropriate hypothesis versus the appropriate alternative. The test scores are, so ito yung mga given natin na test, yung mga scores nila dun sa test. So, we have here yung 94 down, 95, 48, and so on. So, kung bibilangin natin to, we have the 5, 10, 15, 20, 25, 30, 33 samples. So, I mean, itong overall na to, na kinuha natin is 33. And then, sabi natin, we have the step-by-step para makapag-solve tayo sa hypothesis, to determine yung hypothesis natin. Yung first natin is to determine daw yung H sub 0 natin, which is the null hypothesis, and we have the H sub 1. So, let's say we have here naman, yung given naman na natin is we have the mean score is which is the 75. And we also have here naman na yung category natin na pwede natin makuha yung mismong value natin. And ayun na nga. So, we have na for the null hypothesis or the H sub 0, yung mean natin is equivalent sa 75 or the student score is average, which is yung average natin is yung mean natin na 75. And sabi natin, yung sa alternative is hindi siya same sa null hypothesis natin. So we have here yung mu natin or yung mean natin is not equal to 75 or the student score is not average. And then for this problem, ang given natin na significant difference is we have the alpha is equal to 0.05. And then ang assumption natin is two-tailed test siya for this problem. So, for this problem, we have yung critical region. Sabi natin, ang given natin is two-tailed test and we have the 0.05. So, babalikan lang natin yung table natin for the 0.05. Ito. And kukunin lang natin yung value ng two-tailed test natin. Yan. So, nakuha na natin, we have naman yung 1.96, which is the two-tailed test natin. So, kung meron tayong two-tailed test, ang graph natin is so yung sa value natin dito, we have yung 1.96 daw. Yung value ng dito is yung positive natin 1.96. Dito yung 1.96 natin, which is ito yung part ng positive and ito yung part ng negative natin na 1.96. So kasi two-tailed test siya. So itong part na to, itong part ng middle na to is yung sa acceptance region natin. And itong part na to at saka itong part na to, ito yung rejection region natin. And since we have yung problem naman, given this sa problem natin, ang formula natin for the z distribution is we have the x minus mean over the standard deviation. So itong value na to is yung x natin or yung x bar natin. Base ito dun sa sample natin na 33. And ito naman yung 75 is the mean. And yung given sa baba, ito is for the standard deviation natin. So, for the formula, ginamit naman na natin dito yung formula for the standard deviation. Kaya tayo nagkaroon ng 15.17 over the square root of 33. Where yung 33 natin is we have here yung sigma over the square root of n. Yan. So, yung 33 is yung number ng samples natin. So, in using the formula of the z distribution, which we have the x bar minus mean over the standard deviation for the z. So, we have here yung value natin na 0.61. And kapag yung 0.61, sabi natin, based doon sa given problem natin, we have yung mean is equal to 75. And we also have yung mean is equal sa, not equal sa 75. So, sabi natin, nasaan ba yung z natin na 0.61? Kung hanapin natin yung part ng 0.61 natin ng z, nandito siya sa loob ng range natin na critical region, which is we have the positive, negative, or plus minus 1.96. So, kung nasa rejection region, itong 0.61, i-accept natin yung null hypothesis natin. So, ang decision natin dito is to accept the null hypothesis. And then for the conclusion natin, since ganun yung decision natin, yes po, sige po. Since ganun yung decision natin for accepting the null hypothesis, so ang conclusion natin dito is there is no statistical basis for concluding that the freshman class in this year is not average. Kasi based on null hypothesis natin, ang conclusion, ang nakuha natin dito is yung student natin is nasa average lang siya. So for this problem, suppose you are a buyer of large supplies of light bulbs. You want to test at 5%. So given naman dito yung significant difference natin, which is we have the 5%. And then the manufacturers claim that his bulbs last more than 800 hours. You test 36 bulbs and find the sample mean is 816 hours. And the sample standard deviation is 70 hours. Should you accept the claim? So, ang kailangan natin masagot is, i-accept ba natin yung claim based dito sa given natin? So, based sa given natin, we have naman yung mismong bulb daw is naglalas ng more than 800 hours. And then, we also have yung sample na 36 bars. And we have yung mean as 816 and also the sample standard deviation as 70 hours. So, first again, we have yung first natin is we need to determine daw yung null hypothesis at saka yung alternative hypothesis. Yung first natin na null hypothesis is we have yung mean natin daw is equal sa 800 or it will not last more than 800 hours. And then for the alternative natin hypothesis, we have yung mean is greater than the 800. or it will last more than the 800 hours. And then also, yung significant level natin na given is 0.05. And since we use the greater than, so possible dito is one-tailed test siya. So either lang kasi mas mataas yung hinahanap for the alternative hypothesis. And then sabi natin, based again dun sa table natin, since na-categorize natin siya as 0.05 and one-tailed test, hahanapin natin yung mismong value ni Z. Where dun sa critical region natin, we have yung Z is equal sa positive 1.645. So for the graph naman, one-tailed test lang siya. So yung graph natin for this problem is, let's say ito yung graph natin, one line lang siya. And we have here yung value ni Z, na which is itong 1.645. And based doon sa given natin, we have naman yung value ni X, which is 816. And we also have the value of mean, which is 800. And then kukunin natin yung standard deviation. Sa given natin na standard deviation, we have naman yung sigma over the sample. So we have yung sample as yung n natin, which is 36, and we have yung sigma natin as standard deviation natin, which is, yung sample deviation natin, which is 70. And then, compute lang natin, we have daw yung 1.37. Kung we have here, itong line na to is the 1.645. Ito yung rejection region natin. Ito yung rejection region. Ito yung acceptance region natin, yung A. So, kapag hanapin natin yung 1.635 sa graph natin, pasok pa rin siya doon sa value natin na 1.645. So, ibig sabihin, ang decision natin is to accept the HO. Yan. So, to accept the HO kasi hindi siya pumasok dito sa rejection. Kaya we have yung sa decision natin as accept yung HO, which we have naman na yung H sub 0 natin or yung null hypothesis natin is light bulbs last more than 800 hours. Not more than 800 hours. So conclusion natin, reject the manufacturer's claim that his bulbs last more than 800 hours. So ibig sabihin, hindi totoo yung sinasabi ni manufacturer na yung bulb nila is naglalast siya ng more than 800 hours. Okay. Ito is additional example lang siya with respect naman dun sa pag-solve natin ulit ng null hypothesis. So we have here na yung example natin is the response time of a distributed computer system is an important quality characteristics that the system manager who wants to know whether the mean response time to a specific type of command exceeds 75 milliseconds. From previous experience, he knows that the standard deviation of response time is 8 milliseconds. Use type 1 error as alpha is equal to 0.05. So we have naman dito for the hypothesis or the null hypothesis, which is given na yung mean natin. So we have mean is equal to 75. And then yung negation ng null hypothesis natin, which is the alternative hypothesis, is we have yung mean as greater than 75. So, based dito, gagamitin natin is yung type 1 error, which is we have the 0.05 for the significant difference, and it is a one-tailed test. So, yun, given na naman na nakuha na din natin dun sa problem natin. So, for this command, we have yung value as yung x natin, which is we have the 79.25 milliseconds. So, gagamitin lang natin siya dito sa given na meron tayong 25, and then for the sample size, and 8 for the standard deviation, x bar or yung sample natin is 79.25 and yung mean natin. And then, after nun, isasolve lang natin yung value ni Z, where we can get naman yung value as 2.66. So, based dun sa table down natin, if we have yung Z of 0.05, we have the 1.645. And then, nakuha natin based dun sa computation ng Z is 2.66. So, therefore, i-reject natin si H sub 0, which is yung mean natin. Kasi yung graph niya, let's say ito yung graph again natin. Ito yung graph. So kung nandirito si 1.645, ito yung rejection region ito yung acceptance region natin. Yung A natin, which is yung acceptance region natin. And then ito yung rejection region natin, yung R natin. Yung 2.66 is mas mataas siya sa 1.645. Therefore, yung 2.66 natin is nasa labas na siya ng 1.645. Kaya yung area na to is rejection na siya. Kaya yung mismong value natin dito is we need to reject yung null hypothesis natin as given natin na meron tayong mean na 75. So, yung conclusion natin, for the conclusion, conclude that the mean response time exceeds 75 milliseconds. Kasi ang inaccept na natin is si alternative hypothesis. Okay, for this discussion naman, since kanina is pinakita natin and then for the last week naman, pinakita natin kung paano tayo mag-solve ng mga mean, ng standard deviation, ng z-distribution, and we also discussed na today and last week kung paano tayo mag-hypothesis testing where we need to know yung sa null hypothesis and alternative hypothesis. Dito naman sa sampling technique and distribution, more on ano muna tayo, mga definition of terms lang muna tayo. Okay. So, for this topic daw, for the week 9, we have yung sampling technique and distribution. Ayan. For this naman, una natin is i-define yung probability sampling. So, probability sampling is defined as a sampling technique in which the researcher chooses some samples from a larger population using a method based on the theory of probability. For a participant to be considered as a probability sample, he or she must be selected using a random selection. So, kapag naman pinag-uusapan natin is yung random or we have this random selection, ibig sabihin, for example daw, meron tayong 1 to 10. Number 1 up to number 10. Kapag sinabi natin na random, pwede tayo mag-select either 1, 3, 5, or kung ano man doon kasi random din naman siya. And considered as probability sample naman, let's say we need to have a sample of 100. So sa sample na 100, ang participant natin is let's say 1 over 100 yung probability na makuha siya. So we have daw the 10%. I mean 1%. 1% of 100. 1% of 100, yun yung probability na pwede siyang makuha as a sample. And then, we have naman daw, ano to? Yan. So, continuation lang, we have yung probability sampling. It is also uses a statistical theory. So, to randomly select a small group or people or yung sample natin from an existing large population and then predict that all their responses will match the overall population. Okay. So mostly ito yung ginagamit sa mga thesis, sa mga research, yung mga probability sampling natin. Pero we have different types of sampling. First is, yung category natin is we have the simple random sampling. Next is we have the systematic sampling. We also have the stratified sampling. We also have yung cluster daw na sampling. And we also have the multi-stage sampling. For the simple random sampling naman, so ito yung madalas na ginagamit sa mga sampling natin. So it is a probability sample in which every member of a study population has been given an equal chance of selection. So ang example natin dito is one way to draw a simple random sample is to put all possibilities on paper, cut them up, and then draw a sample from a hat. And for example nga daw, meron kang mga papel. Let's say, yung bawat papel na yun is may number siya. So, possible na lahat yun is same lang siya, randomly mo lang siya kukunin. Ayan. So, dito, we have also yung the distribution of a sample statistics and a visual display of the samples. Meron ako ditong in-include na picture. Let's say, ito yung mismong population natin. Sa population natin, kung mapapansin mo, iba-iba yung sa population natin. Dito sa population natin, may mga parang magkakaiba yung mga religion nila. Let's say ito is Muslim. And then yung iba dito, may matanda na tayo. Ito, meron tayong given na matanda. Yung iba is mukhang, ano ba to, mukhang nurse. Ganun siya. So magkakaiba. Magkakaiba yung sa population natin. And then based dun sa population natin, either magkakaiba sila ng true age natin, true gender natin, or yung mga profession nila sa religion, magkakaiba siya. Randomly tayo magse-select. So, ibig sabihin, pwede tayo makakuha ng matanda, pwede tayo makakuha ng bata, pwede tayo makakuha ng girl or ng boy, or pwede tayong kumuha ng college graduate, or pwede rin naman na elementary graduate. Ayan siya. So, ito yung randomly selected based sa population natin. So, ito yung sample natin. Let's say, ang overall nito is 20. Dun sa 20 na yun is kukuha lang tayo ng ilang ba ito? 1, 2, 3, 4, 5, 6, 7, 8. Let's say, dun sa sample natin na 20, we can get 8. Sa population na 20, kuha lang tayo ng 8 na sample. And then we also have here, yung second naman down natin is we have the systematic sampling. For the systematic sampling, it is a probability sampling procedure that involves selecting every kth element from a list of population elements after the first element has been removed, selected, randomly selected. So for example, we have here the divide the total number of elements by the number of you want is the sample. So we have here yung sa sample natin na 24 daw. So sa sample na 24, i-divide natin siya sa 6. And then equal siya sa 4. So every fourth natin between the sa value natin or sa mismo, let's say sa tao natin gagamitin siya. So every pang-apat, yun yung isa-select natin. Let's say naman dito, sa given natin, we have yung 9 na tao. Pero magkakaiba sila. So, ito is lalaki, and babae, magkasama na siya. May mas bata, may mas matanda. And then for application ng systematic sampling, let's say, ang kukunin natin is yung every pangatlo. So, we have here 1, 2, 3. So, nakuha siya. Then additional 3 yung number 6 natin. And additional na naman na 3 is ito. So, ang pinagkaiba naman dun sa isa, sa random sampling, simple random sampling natin is wala tayong pattern. Pero for this systematic sampling, we have yung pattern natin which is every third yung pipiliin natin. And then for the example, again, for the systematic sampling, we have yung mismong formula na pwede natin gamitin. So we have here yung selection interval or yung K natin, which is equal sa population size natin. Let's say kanina is population size natin is given is 24, and yung sample size natin is 6. And then every 4 yung nakukuha natin. Yan siya. Okay, for the stratified naman daw, we have the stratified sampling, which is a probability sampling procedure that involves dividing the population in groups or strata. So same lang siya, either groups or strata, defined by the presence of a certain characteristics and then random sampling from each stratum. So ang example naman natin dito, if we have daw yung population natin na 10% women, and the sample is that is also 10% women. Let's say ito naman siya. So, application naman nito, ang standard method naman natin is to arrange naman siya or to classify whether if we want na based sa sex or either female or male siya or sa gender. Let's say gusto natin is yung mga senior citizen na or mga teenager pa lang siya, ethnicity, and yung other similar race natin. So kung as observed dito, pwede natin sabihin na ito is in-arrange siya dun sa mga 40 and above, let's say ganun siya. And then dito naman is in-arrange siya dahil sa sex natin or sa puro female siya. Or dito naman is pwede natin sabihin na based sa ethnicity nila. Yan. So, splitting subjects into mutually exclusive groups and then using simple random sampling to choose members from the groups. Ayan siya. So, yun lang yung for the stratified random sampling natin. Ayan. So we have here naman daw yung steps to draw stratified random sampling. First, again, is to group the study population into strata or yung group natin, or that share a given characteristic. And then next is to enumerate each group separately. And then last is to randomly sample within each strata. And then additional for the types of probability sampling, we have the cluster naman daw, cluster sampling. So the application naman nito, it is a probability sampling procedure that involves randomly selecting clusters. So clustering naman to, clustering of elements from a population and then subsequently selecting every element in each selected cluster for inclusion in the sample. And also the cluster sampling is an option for a data collection that involves visits to sites that are far apart. So, the word itself, so application lang ng clustering for this sampling. Ayan. For this sampling, so analyzes the particular population in which the sample consists of more than a few elements. For example, dito is we can use the clustering into the city naman daw, or based sa family, or ika-cluster natin sila based sa kung saan sila university nag-aaral. So, pwede rin yun for the clustering. And aside from it, researchers then select the cluster by dividing the population into various smaller section. From bigger population daw. So, after natin ika-cluster siya into smaller sections. Ayan. So, for the example again, for the cluster sampling, first is we have you are conducting a study of Kentucky high school students daw. You could obtain a list of all the high school students in the state and complete the random sampling. So, first is we need to to obtain yung list muna based doon kasi kailangan natin magkaroon ng conduct ng study sa Kentucky high school students. And then, para maging more practical siya, kunin natin yung mismong list ng high school lang na students sa Kentucky, and then mag-random sampling tayo dun sa high schools based dun sa list natin. And then after nun, obtain a list of students from each high school selected and then contact each of those students. So, yun yung pwede natin gawin if we will apply this cluster sampling. And then last, for the types of the probability sampling, we have the multi-stage sampling. So for this naman na sampling it is a probability sampling procedure that involves several stages such as randomly selecting clusters from a population, then randomly selecting elements from each cluster. So yun yung pinagkaiba niya dun sa other probability samplings natin. So for the example, you have here yung random digital dial. Yung first stage or yung stage 1 natin is yung area codes, yun yung ira-randomly sampled natin. And then next from doon is we have 3-digit local exchanges randomly sampled din. And then yung last natin is yung last 4 digits naman yung ira-random sampled natin. And then for the stage 4, magtatanong na tayo din sa person who answered the phone for the appropriate person you want to interview. So, kung mapapansin mo dito, we have 3 different ways na nag-random tayo. First is yung area code, sunod is yung 3-digit local, and yung last 4 digit natin na randomly sampled. Ayan. Okay. So, kung kanina, ang discussion natin is focus tayo sa probability. For this naman, we have yung non-probability sampling. So, for the non-probability sampling, subjective judgment naman siya. Sabi natin, it is defined as a sampling technique in which the researcher selects some samples based sa subjective judgment natin. Kung kanina is focus siya sa random sampling, di ba? Yung probability sampling natin kanina is focus sa random sampling. Pero dito, we have the subjective judgment. It is a less stringent method, and this method or the sampling method depends heavily on the expertise of the researchers. It is carried out by observation, and researchers use it widely for the qualitative research. So, itong non-probability, mostly daw for the qualitative research instead of quantitative research. Ayan. Kung kanina meron tayong types for the probability sampling, we also have different types for the non-probability sampling. We have here yung first natin na i-discuss is the purposive sampling. The next natin is the quota sampling. Next is the snowball sampling. And last natin is the convenience sampling. For the purposive sampling, so it is a non-probability sampling procedure that involves selecting elements based on the researcher's judgment. So kasi nga subjective siya, based naman siya sa judgment ng researcher about which element will facilitate his or her investigation. So kung kanina, mostly sa probability sampling natin is we have the random, and then we also have yung kung paano kukuha ng sampling through clustering, and then we also have yung parang stratified din siya, and we also yung gumagamit din tayo ng K. Pero for this is yung researcher mismo yung mamimili ng tao na fit para dun sa research study nila. Let's say, ang gusto ni researcher is lahat is nag-work sa I mean yung lahat is teacher. So doon pa lang alam na kagad or subjective na kagad yung research niya na yun lang yung kukuhanan niya ng sample natin. Kasi yung researcher yung mamimili ng tao na magpa-participate doon sa research study niya. And then for the quota sampling naman daw, we have here, it is also a non-probability sampling procedure that can involve describing the target population in terms of what are thought to be relevant criteria, and then selecting the sample elements to represent the relevant subgroups in proportion to their presence in the target population. So dito naman, yung relevance naman yung important for the quota sampling. And then for the snowball sampling, we have a non-probability sampling procedure that involves using members of the group of the interest to identify other members of the group. Kung mapapansin mo dito, pareho siyang group sa picture, di ba? Ang pinagkaiba lang is, ibang grupo ito, let's say ito is mga, ano ba to, mga may tattoo or mga hip-hop, and then dito is mga bachelor. So, i-identify mo yung members ng group, kung ano yung interest nila, and i-identify mo din yung members ng other group. Doon naman yung ginagamit yung snowball sampling. And then for the convenience sampling naman, we have a non-probability sampling procedure that involves selecting elements that are readily accessible to the researcher, sometimes called the available subject sample. So, yun yung for the convenience sampling natin. So, for here, we have yung choosing the sampling technique daw. First is, it is desirable to sample at all or can the whole population be used. So, dapat i-consider natin yung mismong desirable sample natin and yung mismong population. So, ang population is, ang population natin is yung kabuuan, and then yung kukunin lang natin doon, yun yung sample. And then next, it is important to generalize to a larger population. So, political preference falls na siya. Mas maganda kasi na mas malaki yung population natin kasi mas makukuha natin yung accurate na sagot na gusto natin. So, much better, we have to generalize na yung mismong larger population din. And then, do you have the access and the ability to perform probability sampling? So, dapat i-consider din natin to. Let's say we have now yung, di ba, yung pandemic. If paano ba natin or paano ba tayo makakapag-perform ng probability sampling? Dapat may ability tayo na makapag-perform ng probability or makapagkuha tayo ng sample natin. So, dapat i-consider pa rin natin paano ba natin siya mapo-perform. And then yung other configurations natin, syempre, ito is mostly ginagamit yung probability sampling and non-probability sampling sa mga research. So, ang consideration natin dito is yung methods for the methodology natin, yung mga theories, practicality, and also yung ethics. Yan, yung mga dapat daw i-consider natin. So, in summary, we have here, yung sampling is a means to an end. And we sample because studying every element in our population is frequently beyond our means or would jeopardize the quality of our And on the other hand, we don't need to sample when studying every member of our population is feasible. So, ang goal lang naman natin dito is, yun nga, parang 'di ba, kadugtong din siya nung sa hypothesis testing natin. So, we need to prove something. Kaya tayo nagsa-sample or kaya tayo gumagamit ng mga probability sampling, non-probability sampling is we need to prove something. So, kung feasible siya, yan. Ano yan? Sabi is, we don't need to sample when studying every member of our population is feasible na siya. So yung iba, kaya nag-study is to determine if feasible ba siya or hindi. Itong sampling distribution is na-discuss na naman natin to last time. Ito na yung sa part ng yung mga mean natin kanina. We have the standard deviation, yung sa X-bar or yung sa sample natin. So, dito, medyo nauna ito dun sa discussion natin para mas madali siyang maintindihan. Okay, sige. Thank you. Thank you sa time. Dismiss na. Thank you.